Hello everyone, my name is Patrick. I'm here to give a speech about monitoring red tide with satellite imagery and numerical models, a case study in the Arabian Gulf. What is a red tide? Red tide is a harmful algal bloom result from large concentrations of aquatic microorganisms. And if water containing fertilizer or livestock waste flow into the sea, the water will transport nutrients and stimulate the bloom event. And the red tide outbreaks could force desalination plants to shut down, which pose a major threat to the potable water supply in Middle East. Here is a map of Arabian Gulf. Arabian Gulf is also called Persian Gulf. It is a shallow marginal sea with high evaporation and low precipitation. And a special feature in this region is the sandstorm. The sandstorm occurs frequently in the Arabian Gulf, which brings high aerosol concentration. And the term aerosol means a suspension of solid particles or liquid droplets in gas, and with specific diameters range from 0.1 nanometer to 0.1 millimeter to 1 nanometer. So in the case, we studied the 2008 red tide event, which did harm to local aquaculture, coral reef community, and fishery. And our purpose is to find out the initiation and sustaining mechanisms for the unusual long-lasting red tide event. Here are 4 satellites we use to get the data we need. And we also use satellite images with numerical models to analyze the red tide event. This is an image I take from the satellite CWIFS, and it's taken in August 2008. The color bar shows the chlorophyll A concentration with milligram per cubic meter. And in the Arabian Gulf, normally its concentration is about 1 milligram to 30 milligram per cubic meter. And when the concentration reaches to 5 to 10 milligram per cubic meter, we consider it is a algal bloom. And the blank area indicates no data due to cloud cover or heavy dust. And the algal bloom first seen in August 2008, and it sustained all the way through October and November, December. And not yet, it continued at February 2009 and April, June, July. So through the observation, we can see the algal bloom lasts totally about 12 months. So for the initiation, we can take a look at this picture. This image is taken in August 2008, and the color bar shows the sea surface height. The arrow means the water flowing velocity and its direction. We can see the water here is flowing offshore. And next, this is a picture about sea surface temperature. The color bar here is sea surface temperature in degrees Celsius. We can see the edge of this side is 1 degree lower than this side. So combining these two pictures, we can confirm that there is a coastal upwelling occur here. And the coastal upwelling brings up the nutrient bottom water to the surface, which triggers the first algal bloom. And for the sustaining mechanisms, we need to know what is the aerosol optical thickness first. When the AOT is low, we can see the sky clearly. And when the sandstorm coming, the AOT turns high, and we can barely see nothing. And the color bar here, monthly anomaly, is defined as AOT difference between monthly mean and monthly climatology. We calculate the monthly mean in February 2009 and compare to the monthly mean during 2002 to 2013. And the green part means the anomaly is positive, shows the AOT concentration is higher in February 2009. So we can see the positive anomaly is found in middle and eastern Arabian Gulf along the coastline. So we assume that sandstorm make dust deposition with the element iron, and it can serve as an important resources of nutrient supply. You can see the AOT is high here, and the chlorophyll A concentration is high too. And for the second sustaining mechanisms, we are talking about nitrogen-fixing microbial, the trichodesmium. It is a cyanobacteria mainly found in tropical sea. And this is the pathway how the trichodesmium affect the algal bloom. The enzyme in the trichodesmium will convert nitrogen into ammonium. And the supply of ammonium will help algae grows better. This is an enhanced RGB image, and we take by satellite Aqua in December 2008. And we choose 18 stations to see if there is any trichodesmium there. So you can see this picture. The x-axis is wavelength, and the y-axis is remote sensing reflectance. And we calculate the data we collect from 18 stations by statistics, and to make you easier to understand what is a remote sensing reflectance, basically is we use 5 wavelengths to hit the particle, and each one has different level of reflectance. So based on this feature, you can see the W shape, high, low, and high, and low, and high. We can find that it can indicate the presence of the trichodesmium. So combining the enhanced RGB image with chlorophyll A concentration, we can see that here we find the nitrogen fixing microbial, and it may sustain the algal bloom here. So in conclusion, we did find the most possible initiation and sustaining mechanisms for the red tide event in Arabian Gulf. The initiation is coastal upwelling. and the sandstorm and the nitrogen-fixed material may sustain the algal bloom. And it can help local government to find the algal bloom earlier and make a solution to resolve it with manual collection, herbicide, goose and swamp is the already known solution. Okay.
I think he sometimes stops in his sentences is a little bit strange, but he puts many images and figures is clearly and it's easy to understand.
And I think the terms in the paper explain very well with the images, and the figures are easy to read, and also he guides the figures very well.